Welcome to the fourth virtual office hours for the 2014 POSA MOOC. As is our custom, we'll start out today by going over my solution to week 3 assignment 2, which is the assignment that was due and that people are peer reviewing. We will then go ahead and talk about next week's assignment, and I'll show you the shells and of course be happy to answer any questions you may have about that. I'll walk through the assignment as well so you kind of get a sense for what it is you're supposed to be adding. And then we'll answer any questions that you might have about any of the topics that are on your mind. We'll also go through the website and look at the discussion subforum for the fourth virtual office hours, and I'll answer any questions there that haven't been answered already. And then we have a special guest lecture from Mike Walker, who is going to talk about Git and GitHub and how to do source code control using Git. As I mentioned before in one of my earlier announcements, we'll actually be recording 2 videos. This first one that I'll do will be a separate video from the one that Mike will do. And so I'll create 2 different videos, and that way people who don't need to learn about Git don't have to watch the Git video. People who do want to know about Git can watch the Git video first, whatever happens to be what works best for you. So let's go ahead and start first by looking at my solution to the assignment. Let me go ahead and share my screen. So hopefully you can see it. Okay, so there is the screen. Go ahead and go find the source code. Here is the source code. And as I walk through this, I'll talk about a lot of the issues that have arisen from questions we've seen on the news group or on the discussion forum. Okay, so here's what you have to do. Keep in mind that there are 2 parts, one of which is really just cutting and pasting your solution from the previous week's assignment after you added any improvements that were discussed in last week's virtual office stuff. So I'm not going to go through this one again. This is the simple atomic long implementation, but you should have uploaded that. Note, by the way, if you read the assignment carefully, and I strongly encourage everybody to read the assignment carefully, you didn't actually have to use simple atomic long in your simple semaphore implementation. It was really intended to be used for the Palantir Manager test case and unit test. So let's take a look at the simple semaphore. There were a bunch of to-do clauses you had to fill in, and the first couple had to do with defining the appropriate kind of locks. So you needed to define a rentrant lock. As you can see here, I made rentrant lock called mlock, which is private because nobody else needs to see it externally except the implementation of the class. And you'll notice that I don't actually implement the lock when I define it. I defer that into the constructor, and you'll see why in just a second. The next thing we have is a condition. The condition is an interface, and the condition interface, as we'll see, is actually used to do various things. And one of the most important things we're going to be able to do with the lock is go ahead and get ourselves a condition from that, and that's how it'll get initialized. Hopefully this is pretty straightforward. Oh yeah, good point. Let me go ahead and make the font a little bigger. Thank you, Mike. That's a good suggestion. Make it a little easier to see. There we go. So here is the font. Hopefully you can see that better. Now, the next thing we're going to do here, and there's a number, so there aren't really a whole lot of different ways to do the lock and the condition, but the next thing, there's a couple different options. So as you can see, my particular implementation for the count of the number of available permits is a volatile int. You don't have to put the word volatile here. If you don't put the word volatile here, your program can still be perfectly correct. It just needs to make sure that you protect access to the available permits in the available permits accessor method. Do not, however, make this static. If you make this static, that is incorrect, and that's because there'll only be 1 count of available permits for all the instances of Semaphore. So do not do that. That's actually a mistake, and I would count a point off if someone put the word static there. Even if the unit test didn't catch it, it's definitely the wrong thing to do. So that you can either have this or this, but if you have this, you have to do some additional locking. All right, now let's go take a look at the constructor. I actually went ahead and tweaked this master implementation a little bit. This is not exactly what you have in your assignment, but based on some feedback, I wanted to clarify for future implementations of this that initial permits potentially be less than 0. If somebody does not write code that treats initial permits as being less than 0, that's okay. It wasn't originally specified in the requirements, but to be consistent with the way that Sun and Oracle define the semantics of Semaphore, initial permits can start out with a negative number. Why on earth you'd want to do that is another question, but that's how it works. I should also point out, by the way, that the dictionary definition of a semaphore is a non-negative integer, but the implementation that comes with Sun and Oracle allows the implementation values to be negative. And we'll talk a little bit more about that when we look at the implementation. So here's my implementation. By the way, I also changed the name to initial permits to try to avoid confusing people who thought this was some kind of maximum. It's just the initial count of available permits, which can actually grow to be higher than the initial count. The second parameter to simple semaphore constructor is a Boolean parameter that is used to indicate whether something is fair or not. And you can see here that the implementation is very simple. We make a new reentrant lock that is fair, and then we go ahead and use that lock to make ourselves a new condition. And so now we've got things initialized. Now, there was some nice discussion in the discussion forum about whether or not this really provides you with guaranteed fairness. And from what I can tell, the documentation is a little bit ambiguous about this in Java. It looks like the intent is if you make yourself a fair reentrant lock, then the condition object that comes back when you call new condition on said fair reentrant lock should also be fair. But it's a little bit unclear what that exactly means. It looks pretty accurate unless you do some crazy things by adding sleep statements and so on. It should be fair, but I would not bet the farm on this, as we say. I would not guarantee it. Obviously, in real life, if you want to have a fair semaphore, you should use the Java semaphore, which does the implementation slightly differently. But this is certainly good enough for our teaching purposes. Okay, so that's basically what the constructor should look like. Note there is no need to have a use of a lock in the constructor. If you watched last week's virtual office hours, we talk at length about why it shouldn't be necessary to put locks in constructors to force visibility of the members if you follow the right patterns, which are discussed in last week's virtual office hours. Okay, let's look at the acquire method. There are two acquire methods. One acquire method can throw an interrupted exception, and the other acquire method, which is called acquire uninterruptibly, cannot. And the main difference, of course, is that the acquire method that can throw an interrupted exception might not actually acquire the semaphore before it returns, whereas the one that does the acquire uninterruptibly method will not return until the permit is actually acquired. So let's look at the one that's interruptible first. As you might imagine, it makes sense that if you're going to have an interruptible acquire method, you should use the lock interruptibly method. There's been a lot of discussion about this on the discussion forum. I think it's perfectly fine from an implementation point of view if you just do this, if you just use regular lock here, which is not interruptible. The only difference will be that your solution will not be as responsive, perhaps, in being interrupted as might otherwise be the case. But in this case, we come ahead, we do a lock interruptibly. Now, if somebody interrupts this, that means that the interrupted exception will be thrown, and we won't even get into the try block, which is perfectly fine. So in that case, no harm done. We never acquired the lock. We just bail out. If we acquire the lock, and then an interrupt occurs, notice that the interrupts in Java are not asynchronous. They have to be either tested for explicitly or they have to be used implicitly when you call methods that can be interrupted. So we never have a problem where an interrupt will suddenly occur between the return here and when we get into this try statement. So that's not an issue. Now let's talk about how we're going to wait if we don't have permits. Keep in mind that my implementation here allows negative permit values in the constructor. So in that case, we have to go into a try block, and while the number of available permits is less than or equal to 0, we have to wait for the permit to be incremented to the point where it's not less than or equal to 0. It's perfectly okay to just do this, to say equals 0, because the specification that we put out did not say you have to be able to support negative permits. So it's okay to have that, but my implementation is more like the Sun implementation in that it will support negative permits. So this is basically what's called a guarded condition. This is the guarded suspension pattern that we've talked about in the videos. And what it does, and this is very canonical, it's the way that you typically work with condition objects. While some condition is not to your liking, in this case we don't have a permit, we're going to wait. And wait will basically park us, or await, it will basically park this thread until somebody signals it. Now keep in mind that oddly enough, even though lock is non-interruptible, await is interruptible. So this is a little confusing. Clearly the guys doing the condition objects and the reentrant locks didn't coordinate their naming conventions, but be that as it may, when you call await here, await can be interrupted. So if somebody interrupts this thread, then this is going to end up throwing the interrupted exception. And that's why it's absolutely essential that you actually put this particular piece of code in a try finally block, or do something here to make sure that if an interrupted exception occurs, you will guarantee to unlock the lock no matter how it is you exit this block of code. So we'll go ahead and wait for a signal or an interrupt. If an interrupt occurs, then an exception is thrown, in which case the finally block is run to unlock the lock. If we are signaled, then we loop back around again and we check to see whether available permits is greater than 0. If it's not greater than 0, and there's a lot of reasons why it might not be greater than 0, we'll just go back to sleep. So just because you're signaled doesn't mean that you necessarily find the world to your liking. The state may not be what you want. So you have to keep checking. As a general rule of thumb, probably very rarely, if ever violated, you always want to make calls to wait or await be in loops. And that's discussed in the video and discussed in many places online and in good books on Java and condition objects. Assuming we finally get through our guard, in other words, the number of permits is now greater than 0, the lock will be held. Notice every time a wait is called, it releases the lock and goes to sleep atomically. And when a wait returns after it's been signaled or interrupted, the lock is reacquired, and so we can check or we can modify available permits without having to worry about race conditions. So we decrement available permits by 1, and then no matter what happens, we unlock the lock and we're done. So this particular method will either have acquired the semaphore and reduced the available permits by 1, or an interrupted exception will have occurred, in which case it will do nothing. All right, let's take a look at acquire uninterruptibly. Acquire uninterruptibly is very similar. In fact, the basic logic is identical. The only difference is the types of locking mechanisms we call. So instead of calling lock interruptibly, we call lock, which by default is not interruptible. That means that if an interrupt is posted to this thread, it will just be ignored. So this will only return when it actually has access to the lock. We go into the try block. While the permits are less than 0, we await uninterruptibly, so that means we will not be released, we will not be unblocked when an interrupt occurs. And logic is identical as before. The only difference is we are not leaving this method if an interrupt occurs. So the only way we're going to leave this method is if we're signaled and the permits turn out to be greater than 0, in which case we decrement them by 1 and unlock. So I guess in theory, you don't need a try finally block in theory, but boy, I sure would be a little reluctant to program like that. I just feel better following these patterns, even if I don't absolutely have to, because it makes the code a lot easier to maintain and understand. All right, so that's uninterruptibly, pretty straightforward. Obviously, you would not want to call lock interruptibly in acquire uninterruptibly. If you say this, it's wrong, because now you're going to leave this thing potentially without actually having acquired a permit. Okay, let's talk about release next. Release is also very canonical. It always looks kind of the same way. I can either say ++ m available permits or m available permits ++. Either way is perfectly fine. Any half-decent compiler will turn that into identical code. There should be absolutely no performance difference between the two. There might be a performance difference if the result was assigned to something, but it's not, so they should be identical. Once again, we acquire the lock. In this case, we're acquiring the lock uninterruptibly, and because it doesn't throw an exception. And then down here, we do a little optimization. This is optional. So first, we increment the number of available permits because we're releasing them. And then we have a little optimization. This is not strictly necessary. The code is perfectly acceptable if you don't do this optimization, if you just signal. But if you want to do the optimization, what you're doing here is you're saying only signal if there's a chance someone can be awakened to do some actual work. And the typical reason why this would be necessary would be if you allowed negative semaphore values to start out with. So until that semaphore value is greater than 0, there's no sense in waking anybody up, because all they're going to do is just basically go right back to sleep. So that's just a wasted trip through the scheduler of the monitor, of the condition objects. All right, something else here that's important, and a lot of discussion taking place on the discussion forum about this. Notice I use signal here, not signal all. It is unnecessary to use signal all here. If you use signal all, it's not wrong, it's just unnecessary, and you ought to understand the reasons why it's unnecessary. So to make that clear, let's see if I can find this quickly for you. Let's see if you can find a web browser somewhere to illustrate this point. Let's see, let's try that one. All right, so let's go back to the class. And I probably should have pre-cached this one because I knew I wanted to talk about it, but I forgot. But I think I know how to search for it. So let's go look at gets notify all. There's a really great book on Java concurrent programming by Brian Getz and Doug Lee and a bunch of other people. And Joseph Allegris was kind enough to extract a little snippet of the book that explains the conditions under which you could use signal instead of signal all, or notify instead of notify all. And so the basic idea here is that if you're only waiting on one predicate and you want to have only one thread wake up, then you can go ahead and use notify or signal. If you're waiting on multiple predicates and or you want multiple threads to wake up, then you would use notify all or signal all, depending on which mechanism you're using, of course. And as you can see here, whoops, hold on a second. For some reason, this isn't showing up. Let me fix this. Got to find the right thing. Let's see. Sometimes Google Hangout is a little persnickety as far as which screen it's actually. There we go. I think this is the right one. All right. So here was the entry that Joseph had posted. This is if you search for gets GOETZ notify all in the search window, you'll get this little summary that Joseph was kind of to extract from Brian's great Java concurrency and practice book. And this is where he basically lays out the rules for knowing whether to use notify or signal versus notify all or signal all. And you can see uniform waiters, one in, one out. Those are the conditions. And that turns out to be the case for our simple semaphore. We have one thing it's waiting on, which is whether the permits are greater than 0, and we have only one waiter we want to wake up. Now, the reason why you really want to know this is because it turns out that notify all and signal all is very inefficient. So using them excessively does not buy you anything at all, and it will make your code slower. So that's probably important to understand. By the way, you might wonder why there's so many things online saying to use notify all, and that's because people are typically referring to Java built-in monitor objects where there's only one monitor condition per monitor object, and therefore you often are actually waiting on multiple predicates. So that violates the Brian Getz rules, and so therefore you do need to use notify all, which is yet one more reason why it's often better to use condition objects and signal rather than using built-in monitor objects where you have to use notify all, because it's clearer and it's also often more efficient. So Um, let's see. Why is the reentrant lock final? So when you say final, I'm not exactly sure where you want to put final, but you see up here, if you were to put the word final here, then we'd be out of luck because we have to initialize it down here in the constructor. And the reason we have to initialize it down here in the constructor is because we need to be able to pass in whether it's fair or unfair, and that comes in. The null.
Yeah. Well, no, you don't put null at all. You just don't put anything.
Oh, okay. So yeah, I guess we could put the word final here if we want to, and then it'll get initialized in the constructor.
But it has to be initialized.
It has to be. Okay, so we can use final there. That's fine. Let's see. What was the other question?
Why isn't there is a lock final or not final?
Okay, so we've addressed that one. What was there another question?
So they want to know why you would use final and why you wouldn't.
Oh, just in order to further clarify that it doesn't change after it's initialized. Okay, so there's release. Hopefully that answered all the questions that I saw on the forum. There are various ways to do all this stuff, as you can see. For the purposes of grading, the most important thing is that the solution be correct. If people have solutions that are inefficient, that's okay. I mean, it's not good. I would put comments in the comment section instructing people on how to make it be efficient. If you're using signal all versus signal, you put a comment in, don't take points off. If you end up putting excessive signals in the acquire and in the acquire methods, I guess that's okay too if it's not incorrect, if it doesn't lead to the wrong results. Again, I would put comments in saying it's not necessary. The goal here is not to take points off gratuitously. It's to make sure that people's solutions are correct, and much more importantly than assigning points, it's to make sure people understand why they do things they do. Here's the implementation of available permits. Because we made available permits volatile, then we can just return the value here. If you don't make available permits volatile, then you'll have to acquire the lock, just like we did in the other methods, and then go ahead and return it with a lock held. This, of course, is a little bit excessive to do that because we're really just reading this value, and the reentrant lock that we're using here is a write lock, so it doesn't optimize for readers. So that the key thing is you don't want to be returning unprotected values that can be accessed simultaneously from multiple threads. And the reason is because you'll end up potentially getting the quote wrong value, or you could get multiple values that were out of date or obsolete. There's a number of discussions about this on the discussion forum, and I provided some links to various resources to learn why you do not want to be reading these things without having locks held. By far, the easiest thing to do is to just make the available permits member a volatile, and then all the problems just sort of magically go away for this particular case. If you make it volatile, please don't acquire and release the lock. That's a belt and suspenders approach that's overkill. Again, if somebody were to do that, you don't have to take points off. It's not wrong. It's just unnecessary. So please leave comments explaining a better way to do it. Okay, so that's basically the implementation. I think we covered pretty much everything I wanted to talk about there, but let me go ahead and see if there's any questions that we haven't addressed. So we made the lock final. That's addressed. Question, why is it less than or equal to 0 versus 0 when we check the condition? As I mentioned before, if you want to have an implementation that supports negative permits, which is perfectly fine, that's the way the Java semaphores work, then you need to check for less than or equal to. If you just want to have one that supports non-negative values, either 0 or greater, then you can check simply for 0 as opposed to less than 0. Let's see, hopefully the fonts are bigger. Is the try block for the acquires necessary? The try block is absolutely necessary for the acquire that will be interrupted, because otherwise an interrupted exception could cause the unlock method to not be called. For the case where we do the uninterruptible acquire, it's not necessarily necessary, but I sure as heck would put it in there in case some other weird kind of exception was to be thrown. Let's see, why do we need additional checks for available permits if the condition in the waiting function So check whether it can access an object. Roman, I'm not really sure I understand your question. I guess you're asking, why do we have to recheck whether available permits is less than or equal to 0 in a loop, as opposed to simply assuming if we are signaled, we're good to go. And the reason for that has to do with the inherent non-determinism of multi-threaded programs. It might be the case that between the point when you were signaled and when you reacquired the reentrant lock, some other higher priority thread came sneaking through, acquired the lock first because it was higher priority, and as a result, it would go ahead and decrement the permits count by 1. So because there are 2 steps, being signaled and acquiring the lock, which is inherent in condition objects, you need to always, always, always make sure that you recheck the condition in a loop before you continue on. That's just very, very basic condition object 101 kind of thing. If you take a look online, lots and lots of places that explain this. It's also explained in the videos in several places. Is it okay to use atomic integer instead of volatile int for the available permits? You can certainly do that. It's not incorrect. It's inefficient. So if someone were to do that, then in the comments section, please point out to them that that was explicitly mentioned in the assignment to not be done that way. So they should not do that for real, but it doesn't make their program wrong, so don't count points off for it. Should we take points off if someone used lock instead of lock interruptibly in the acquire method? No, it's fine to use lock. It just makes the solution less responsive. It's not necessarily wrong. But I would also leave a comment. I put the lock inside the try block. Is that a problem? It depends whether the lock throws an exception or not. I think you're probably okay, but the idiom in Java is not to put the lock inside the try block unless you're trying to grab the exception for some reason, which you don't need in this case. One of my students initialized the lock outside the constructor. That is not correct because it means that they can't pass the fair parameter to the lock that came in with the constructor, so that's actually incorrect. All right, I think, let's see if there's any more questions. Is it okay to not use final as long as we make sure there's no change to lock? It's certainly fine to not use final. That is not required. That's just a hint or a directive to the compiler saying, I promise not to change this thing after it's constructed. Is there any value in adding a check to see if the thread, an explicit check to see if the thread has been interrupted? I would not add that. There's really no particularly good reason to do that. The better thing to do is to make sure you call the version of lock that can be interrupted, and then you don't have to make the check explicitly. It's not incorrect to do that check unless you do it in the acquire uninterruptible call, in which case it is incorrect because you don't want to leave that call at all. Let's see. All right. Oh, by the way, you should also be getting a realization that because things pass the unit test doesn't mean that they're correct in any way, shape, or form. The unit tests are just there to help kind of catch the really gratuitous problems. As we talked about before, we're always looking for improvements to unit tests, and we're also hoping to use more advanced tools in future offerings of the course as we get more time. Can the method available permits be called in the while condition instead of accessing the variable directly? Oh, good question. The basic question here is, can you make a method call to available permits instead of checking the M available permits data member? You can certainly do that, but be aware it's going to be slower because it's going to be either making a method call, or it might be actually acquiring a lock. So it's not wrong. I just wouldn't recommend doing that. If you want to have an accessor method, use the thread-safe interface pattern that we've talked about in the previous SRs. Let's see. So we already talked about finally. Could use M available permits plus or plus plus M available permits. Either way works fine. I talked about that already. It doesn't matter for this particular case. The optimizer will get rid of that. In the release method, isn't the if block unnecessary after the available permits counter? It's not. It is not strictly necessary because it'll work fine if you don't make that check. It'll just end up causing potentially more trips through the condition object scheduler. On the other hand, if you don't use negative values, you probably aren't going to have situations where you need to benefit from this optimization. So it's purely there as a potential optimization. If someone doesn't put it in there, not a problem. Don't take any points off. It's perfectly fine to do it that way. What's the default access setting for class members in Java if we skip the keyword? It's package public, I believe. I don't like to make things implicit, though. I like to make them explicit as much as I can remember. Let's see. Okay. Is it not better to declare? Oh, you want to use a lock? Yeah, it's fine to use an interface if you want to, as long as that works. Not a big deal. Let's see. If somebody didn't use the right shell, then if you feel like being lenient, that's fine. But people really need to get in the habit of learning how to use Git to get the new versions of the assignment. And we'll talk about that shortly. But if you want to be lenient, that's okay. It's perfectly acceptable to initialize final data member in the constructor. You are correct. We fixed that. Can you add this code somewhere to be a reference in the course? No, we're not going to be giving the solutions out directly for various reasons, not the least of which is people need to be able to go back and improve their solution from last time. And that's part of the next assignment, is to create a simple semaphore that's, quote, correct. Just like for this assignment, it was appropriate to make a simple atomic long that was correct. And I don't want people just blindly copying my code and pasting it in. I want you to spend the time, go back, watch the video, figure out your solution wasn't right, and fix it. Because you'll learn a heck of a lot more by taking the time to do that than simply by cutting and pasting my code. So that's one of the reasons why we're not going to put the code out. You can certainly watch the video, though, and understand the concepts. The most important thing in this class is to learn the reasons why we do things in certain ways. And so simply getting the solution right by cutting and pasting it is not helping anybody at all in the learning process. What would happen if we don't use final on the lock and it's changed later? Probably bad things, so don't do that. Should a signal only be sent on a transition from 0 to 1 permits? That's basically what that optimization was doing. But it's not necessary to do that, it's just an optimization. Is it an error to put the M available permits decrement inside as if an N available permits block? I'm not quite, Greg, I'm not quite sure what you're asking, so you might want to repost your question with a little snippet because I don't quite know what you're asking there. Should we deduct points for using signal all? As I mentioned before, just because it's inefficient doesn't mean it's wrong. I would put a comment in the comment section recommending people read the Brian Getz snippet that Joseph posted so that you can learn why it's correct to use signal in this case, but I wouldn't count off points. With acquire uninterruptedly, I saw await inside a try catch block, empty catch clause. Is that okay? Probably not, because you're not, unless you put it in a loop and you go back again and again and again. The requirement is you don't leave the acquire uninterruptedly method until the lock is acquired. And so you need to absolutely make sure that you don't leave until that condition is set. So it kind of depends on how they implement it as to whether it's right or wrong. Does the release method require a try finally block? It might or might not. We'd have to go look and see what kind of exceptions Signal could generate. If Signal doesn't generate any exceptions, you're probably okay to omit the try finally. But again, just a good habit to get into. Rather than trying to guess and figure out what these things do, use try finally. There shouldn't be a performance impact. Oh, okay. Let's see. If M permits greater than 0, M permits minus minus. Not sure what the question is. Manish, please re-ask it. Can you increase the font size? Done. Okay. Should we deduct points if the await loop is not inside a try block? If anything can throw an exception and it's not in the try finally block, and the lock cannot be unlocked, then you should deduct points. So that's the rule to follow. That's a general rule. If the decrement inside the condition until available permit. So Manish, go ahead and post that to the discussion forum. I really can't, I don't have time to figure out what you're asking, so just post it up there and I'll take a look later. Is the use of signal within the acquire methods after modifying the number of permits an error or just inefficient? Use of signal. If you call signal within the acquire methods, I think that's probably okay in the sense that you're semantically correct. You'll get the right result, but is that unnecessarily inefficient? But as we said before, our rule is we only take points off if the answer is wrong, not if the answer is slow. Obviously, if this was a work environment and we were writing production code and I was your manager, and you kept writing code that was really slow, I might not be so generous as I am in this case, but this is just a teaching class, so I wouldn't worry too much about it. When I asked about signal all, not on the release method, again, same answer. People are asking the same question over and over again. If the result does not create incorrect, if the code does not create incorrect results but is slow, then it's fine. Don't take points off. I don't know how to say that any more clearly. How should we grade the release method if there's no try finally block? Go take a look and see if signal can throw an exception of some kind, and if it can't, then it will be fine. mlock, have a final also done. Is the try finally block required for acquired? Already talked about that a number of times. Again, the rule is make sure you use try finally if code you call can throw exceptions. That's the rule. So you don't have to keep asking all these special cases. That's the rule to follow. It's much better to understand the rule than to try to ask a million special cases. Okay, so let's see. I think you can use lock if you want to. All right, I think we're coming down to the wire here, so we're going to switch over in a second. Let's see. Put return after M available permits. So I'm not sure, Massa Milano, what you mean. Post questions like that to the discussion forum. Again, if somebody's returning in the middle of a function without releasing the lock, or it's not using a try finally block, then no problem. All right. Okay, I think we're running out at the end of the questions about this. This is great. So what I'd like to do now is talk about the next assignment, and then when we're done with that, we'll answer any general questions that you have, and then I will go ahead and talk about anything else you've got, and then Mike will take over. Oh, wait, hold on, a few more questions. Someone did a check after a wait to see if the thread was interrupted. It's probably not necessary to do any explicit checks for interrupts in there. That may or may not make the code wrong, so take a careful look to make sure if it meets the requirements. Let's see. All right. Okay. Let's move over to the next assignment, and we'll start talking about that. Okay, so here, hopefully the screen is showing up again. Go ahead and get rid of the code I was looking at. All right, here is the shelves for the current assignment, or the one that you're working on right now, that we'll talk about the solution to next week. One of the pieces of code that you have to write is the simple semaphore. So hopefully after this discussion we had today, filling in simple semaphore will be a snap. Just go back and improve that. That again, just to reiterate, that's why we're not putting the code out. We want people to take the effort to go back and improve their solution. That's part and parcel about what it means to be a good software developer, is learning to maintain code that you wrote over time so it'll be more reusable. What you'll be filling in is the so-called ping pong wrong class, and what I'm going to do here is kind of walk through it and talk about some stuff. Here's a method that's the number of iterations. This probably could be removed. We'll probably remove it for the next version. It was left over from a test program that was done earlier. You can kind of ignore that one probably because it's passed in as a runtime parameter. Here is the latch that's declared every time a thread exits. As you can see, it's set to null. We're going to initialize it later. We'll talk about that. Oh, by the way, as you'll see later, you don't strictly have to use a countdown latch here. You could actually, in this particular case, just use the thread join mechanisms, but we used countdown latches for two reasons. One, because we've been talking about countdown latches in the videos, and I wanted to give people a chance to learn how to use them. And second, it kind of foreshadows or previews the next assignment where you have to use a countdown latch or something along those lines to provide barrier synchronization. So using it here is not strictly necessary, but it's good practice, and it was just a fun way to explain how to do it. Here's the main class, ping pong thread, which extends thread. I defined a couple of final statics ints that are used for my implementation. You're welcome to not use these if you don't want them. They're not going to harm you. We'll take a look in a second and see how they're used. Here's a number of loop iterations. This is passed into the constructor. Here's what you have to do. You have to create a string that will also be initialized in the constructor, and that string, of course, will either print ping or pong, or actually it'll print whatever you pass to it, as the driver program shows. The default is to print ping or pong, but for the test cases we printed A and B because it was a little simpler and more concise. You now have to create two simple semaphores. There's a couple ways to do this. The way I did it was to create an array of two entries, and then I used these static ints, final static ints, as indices into the arrays. That's one way to do it. You don't have to do it that way. You can define two simple semaphores and call them first semaphore and second semaphore if you want, or semaphore A and semaphore B. There's lots of leeway there. Either way, you feel like doing it, as long as it works correctly. People have asked the question, can we get by with a single semaphore? I think the answer is definitively no, though I'm always willing to be proved wrong. But so far, nobody has been able to show a way to use a single semaphore that is correct, where correct means that pings start before pongs and so on. The constructor takes a bunch of parameters, and they hopefully do obvious things with them. They assign them to the data members. That's pretty straightforward. The run method, of course, is going to be called back when the play ping pong thread is started, or when an instance of play ping pong thread is started. And this is basically a main event loop, and all it does is it just runs there, and it acquires the semaphore, acquires the appropriate semaphore, prints out the appropriate string, and then it goes ahead and releases the semaphore. And of course, it does that in a loop. And how long do you loop? You loop for max iteration times, and every time you print it, you print out ping or pong, whatever the string is, and also the iteration number. And hopefully that's clear from reading the assignment description, where it shows what the output should look like. So that's basically what that is. Here's a huge hint. If you go watch the videos on Java synchronization and scheduling example, you will see pretty much how to do this, so a good incentive to watch the videos. In fact, as a general rule of thumb, I strongly recommend watching all the videos that are mentioned in the assignment description before you tackle the implementation of the assignment. It's perfectly fine to look at the assignment first, but watch those videos first, because you will often learn a lot of things that will make your life easy, or easier. Here's the method for acquiring the semaphore, and so basically what you're going to do here is you're going to acquire the semaphore. I would recommend acquiring the semaphore uninterruptibly, because as you can see, acquire does not throw an exception here. So you need to do something that will not throw an exception. So my implementation now uses acquire interruptibly or uninterruptibly. And so what you do is you basically go back and forth. Acquire will acquire the first semaphore, and then release will then go ahead and release the second semaphore. And as you can imagine, you just call release here. You're calling release on the semaphore. And that's why we have two semaphores. One is acquired, one is released, and they alternate going back and forth and back and forth and back and forth. So that's kind of how it works. Let's now take a look at the process method. This is the guy that does all the main work. As you can see, it's passed in the start string, which is used to say something like test is starting. It's passed in the ping string, which could be ping or A. It's passed in the pong string, which could be pong or B. It's really up to the driver to decide how that works. And then it's also passed in the finish string, which is used when you're finished. And then it is passed in the number of iterations to run. Now, here's where you actually have to do some work. So here's where you have to initialize the latch to the appropriate number of countdown latches. Or you initialize countdown latch constructor to the appropriate number. I'll give you a hint. There's two threads, so you need to wait for two things. So hopefully that's pretty clear. The reason this goes here, of course, is that it needs to be reinitialized every time process is called. Now you go ahead and you create two semaphores, a ping semaphore and a pong semaphore. the ping semaphore needs to start out unlocked, and the pong semaphore needs to start out locked. So we're using our simple semaphore as a binary semaphore, even though it's got the potential to also be a counting semaphore. This is just exactly the way that Java semaphores work. So obviously, to make a semaphore unlocked, you're going to give it a parameter that will make it unlocked so someone can acquire it. To make it locked, you have to give it an initial permit count that will start out locked. So hopefully that's pretty straightforward. Again, if you watch the video, you'll find out more about that. We now print the string to start things up. And now we go ahead and we make ourselves a ping, play ping pong thread object, and a pong, play ping pong thread object. And basically what you're going to do there is you pass in a ping or a pong, depending on what you're doing, or the ping string or the pong string, which could be A or B if the test case is the unit test is calling this thing. But normally for the actual application will be the string ping or the string pong. And then you have to pass in the appropriate semaphores. And again, watch the video. It shows a very clever trick where the ping semaphore passes the ping version of play ping pong thread passes the ping semaphore first, followed by the pong semaphore, whereas the pong play ping pong thread passes the pong semaphore, followed by the ping semaphore. And the whole clever thing there is that way they will correctly alternate going back and forth, starting with ping. When all that stuff is done, when you've initialized those objects, you go ahead and initiate them. Hopefully you know by now how to make threads start, that pretty much basic Java threading 101. And then the last thing you do here is you simply replace this call that throws a new interrupted exception, which is just a placeholder, with something that will wait for the other threads to exit. And big hint, you're going to wait for the countdown latch to hit 0. So watch the countdown latch video and it shows exactly how to do all that stuff. And that's about all there is to it. Here's the test program itself here. Just goes ahead and calls process with ready, set, go as the start string, done as the finish string, ping and pong as the strings that are used to print the output. If you look at the JUnit test, people were wondering why there were A's and B's. The JUnit test calls process in a big loop, and as you can see, every time it calls process here, it passes in A and B. And the only reason to do that was just so that we could have a more concise way of checking to see if the output is correct or not. So that is basically an overview of the Play Ping Pong program. Let's see what the questions are. mlatch takes the role of ping join and pong join. Yes, Andre, that's exactly right. So as I said, you could use join here if you wanted to, and your program would work just fine. But when you take a look at the next assignment, the one that comes out after this, you'll see that we have to use, or we don't have to use, but we choose to use countdown latches for a variety of reasons. So I was just giving people some practice with how to use them. Is there any reason to check the lock is held by the thread before unlocking? I think this is probably a question left over from the last discussion, but no, you don't need to check if the lock is held by the current thread before unlocking. That's unnecessary. Is it true that if the solution is correct, there's no output? Well, I'm not sure what you're asking here. If you're asking this for the ping pong test, then when you're running the JUnit tests, there is indeed output. It's just coming out in a different way. By the way, I strongly, strongly, strongly recommend people take the time to look at the unit tests to understand how things are working. And when you do that, it's great because you'll learn how JUnit works, and you'll also see how we're actually running this stuff in order to see whether the results are correct. So I think if you run the JUnit test and your program is correct, you'll see output. If something is wrong, then you will see output showing you where it's off. Why don't you decrement the latch in run? So I'm not sure. Let's see. Let me make sure I understand the question. Bring my editor, my trusty editor, back up here again, and go back over here. All right, so here, whoops, let's get out of that guy for a second. Go back into source. So yeah, so the last thing that you need to do in run, good point. Last thing you need to do in run is to decrement the countdown latch so that it's reduced by 1. So the last thing you do in run after the loop is finished is you decrement the countdown latch by 1. And again, please go back and watch the video to see how that works. Thanks for reminding me of that. That's a good point. Let's see. Okay. Craig, yeah, if you probably don't need n max loop iterations. I said that before. That was left over from an earlier version of the tests when we were doing this in one file. Let's see. Points be taken. Waz asking, should points be taken off if the available permit value is not declared as volatile? Please go back, Wa, and watch the earlier part of the video. I talked in great detail about how to do available permits, and if it's not defined as volatile, then it's still correct as long as they acquire the lock in the available permits method. But go back and watch the video. It talks about that. Let's see. So Timothy's asking a question about a weight. I'm not quite sure what the question is. Oh wait, there's a follow-up here. Let's see. Still not quite sure what the question is, Timothy. You're just showing me code. In the acquire method, we have the try block, and inside that, the while loop with its await call. Right after the while block, I check once more to make sure that M permits count as. I don't think you need to do that, Greg. It's probably overkill to do that check. The while loop should make sure that you do not exit until the count is greater than 0. So checking again is unnecessary. It's not wrong in the sense that your program should give the right result, but it's unnecessary. So why do it? I wouldn't take points off if somebody did that. Let's see. Oh, okay. I don't think you want to be doing timed stuff in the release. I'm not quite sure why you would do that. Why you would be doing the countdown stuff there. Okay, so it looks like we are pretty much done with questions about the first 2 assignments, or sorry, about the assignment that I showed the solution for, as well as the assignment that is coming up where I kind of step through what you needed to do. So if there are any more questions about these things or anything else you want to talk about, please feel free to ask them now, and I'll give a minute or so for people to ask their questions. Otherwise, we will switch over and talk about the Git stuff. So let's first see if there's any more questions that people have. Oh, I know what else I need to do. Sorry, one more quick thing. Let's go over real quick, and we will make sure that the questions have been addressed on the Virtual Office Hours website, because that's what I promised I would do. I think a lot of those questions have now been addressed, so hopefully this will be a quick recap. Many of the questions we've talked about here were already answered in other parts of the video, but let's take a quick look. Okay, reentrant lock versus lock. That's probably just asking whether you can use lock. Let's see if I'm correct about that. Yes, it should be fine. It's fine to use lock as opposed to reentrant lock. Again, the real question to a lot of these things is, are you getting the right results, etc. Why is simple semaphore release not public? Why is simple semaphore release not public? That's a good question. It probably should be public. Let me take a quick look and see what is going on there. If it's not public, then it probably needs to be public. Oh, yes, that should be public. All right. Semaphore Java is now public, or will be shortly. Thanks for noticing that. Let's see. Here we go. Let's go back over and James, it is public now. One of the great things about teaching a MOOC is you get an enormous amount of code review done by lots of eyeballs. All right, let's see. Let's start at the bottom. When to run services in the same process versus a separate process. So this is actually going to be covered in the videos that are going to be released for this coming week, which hopefully I'll get done today, or at least by Monday, if not before. There's a nice summary of this that I pointed people to in my response to this question. If you go here, the question really is dealing with services, and why would you run a service as a separate process versus in the same process as the activity. And if you click on this link, it takes you to an article that talks about a bunch of different reasons. One reason would be because you could separate out the garbage collection of the service process from the other activity process. Another reason is that things should be more robust, because if the service fails or hangs, you could write other parts of your application to not hang or fail as a result of that, so things could be a bit more robust. And then another reason, of course, is if you want to be able to share the service by multiple applications, then you need to make it in a separate process. So those are the three main reasons. That will be covered in the upcoming video. How to know if something is correct? That's a very profound question. It's kind of like asking, how will I know if the program will halt? And so let's see. Hopefully a lot of these things have been addressed. So Mark, if there's still anything lurking around here that wasn't addressed in virtual office hours, please feel free to re-raise those questions. I think I'm going to skip through a lot of the ones like that because I think they've been addressed. Let's see, we've got some Git tool stuff. Mike will talk about that in a minute. Questions for peer evaluation on week 3 assignment 2. Let's see if that's something we've already done. Yeah, so I think I'm going to skip through those things. If anybody asked questions in the virtual office hours that we did not get to in the video, feel free to re-raise them, and I will address them here. Let's see, definition of number of available permits. This is the whole thing, static versus volatile versus non-volatile, etc. Those things have been addressed already. Here's a good one. Should countdown be invoked in a finally block? As a general rule of thumb, this is true of anything. If exceptions can be thrown, then if you want stuff to be done for sure before you leave control in a region or a section of code, then you need to put it in a finally block. My implementation does, in fact, put it in a finally block, so that's probably one thing to think about. Let's see. We talked about minus permits versus permits minus. Either one is perfectly fine. Talked about signal versus signal all. Talked about while loops. Let's see. Yeah, we talked about that, about things being less than or equal to 0 versus 0. Either one is fine. Just one will work for negative permits, the other one won't. Let's see. When do you plan to give out the I Remember project assignment? Oh, that's an interesting question. I thought we'd addressed that before. I saw that it's being worked on right now by the folks who are doing that part of the course. The I Remember assignment, which is the 8th and final assignment, will be probably released next week, is my guess, in prototype form or preview form for people who want to kick the tires for it. It's going to focus primarily on identifying and remedying security defects with the original I Remember application. So we basically took code that had bugs in it and made that into a virtue so that people could apply some of the techniques that Professor White is talking about in his videos. All right, so I think we probably, process versus thread. So this is a great question. The way I always think about this is a process is a unit of protection and resource allocation. A thread is a unit of computation that can occur within a process. And Jim has a real nice description of processes, and then I gave some pointers to some lectures from last semester's POSA course, where we talk a lot more about processes and threads in the context of Unix and Windows and stuff. So if you're interested in knowing about these things in great detail, go ahead and take a look at that. All right, well, I think that is probably about it for this part. Let me just go and see if anybody has any last questions. Because you put 3-second timeout in your unit test, is it possible to put await. You could if you want, but I don't think it hurts anything to use await. Mike, what happens if you put a timeout and the code hasn't stopped? It gets shut down somehow, or?
Oh yeah, the unit test actually at the top of it, it has a special notation that after 3 seconds it will automatically fail and kill it.
Oh, good. Okay, so Tim, I think the answer is you don't need to have a timed await because the unit test will shut things down whether you like it or not after the amount of time is done. Should the unit test ignore white spaces and line feeds? It probably could be programmed to do that. If somebody wants to take the time to add those things and push them, we'll take a look at it. That would be great. Is using if instead of while to await correct? No, do not use if, use while. I can't emphasize this enough. You cannot safely use if statements when using condition variables except under extremely circumscribed conditions. And I'm not even going to tell you what they are because I don't want you to even get in the habit of ever doing that. If you think you need to use an if statement as opposed to a while statement, you probably need to think again. Not that there aren't cases where you could use an if statement, but it's a rule of thumb to not think about this and always to use while. Let's see. So question about Git. This is really more of a Mike question, so while you might want to hold this off and ask it again. Mike will show you how to use Eclipse and Git together. I think as a general rule of thumb, he and I were talking this on the way over here, Git was designed by a person or a group of people who really like command line stuff. And that's kind of the way it's meant to be used. It's a miracle that the GUI versions work at all. They do some pretty cool things, but you're really better off if you want to have seamless interaction between Git and Eclipse to learn to use the command line version. I use the command line version. I think Mike uses the command line version. It's absolutely trivial to use it once you understand it, and it will just save you an enormous headache. So he'll talk about that in just a second. Can the assignments always have an output so we can make sure our code is working right? Well, that's exactly what the unit tests do. They check that for you automatically. So you can run the code without using the unit test just fine. The assignment description explains how to do that, and that will give you an output. So you can take a look and see if it's working properly. And you can review and correct yourself before submitting. Yes, you can do that right now. There's nothing to stop you from running the program itself and seeing what the output is. Now, again, the unit test automatically checks to see if the output is correct. If the output is correct, you get nice, happy green marks. If the output is incorrect, you get a window that pops up to show you that the output is not correct. So